I've already done some drugs. I understand.
You taking it in October or December?
I don't know. Well, the October's already been passed.
But you could still sign up and do the late fee for the October. Now the December deadline is like November 6th.
I'll probably do that then.
What, December 12th? Ain't that when it is, December 12th?
I have no idea.
I think it's December. I think the deadline's the 6th of November and the test is the 12th of December. Alright, so here's basically what we're saying. If you have the log of some base b, right, of x, that equals your y. If I was going to take this logarithmic form and put it in exponential form, I'm going to take whatever base that is, b, raise it to whatever exponent this is, y, and that equals this x.
This is a whole new.
Yes, ma'am.
This is like.
Logarithmic function.
How long do we have to
This is
freeze
not
this
fair.
one?
I'm not asking.
Can we know the date on it though?
What?
I don't want to know, but I need to know what
Don't
I'm
get
doing.
all-
It'll be in the grade book tonight.
That's
You can
not.
check your STI tonight. It'll be in
I'm asking, is this like a whole new like
chapter.
chapter?
Yes, ma'am.
Chapter 2.
Chapter 3, actually.
Well, I was calling it chapter 2, but it's the second chapter we knew it.
You are correct. All right, so here's the first question. If we get log base 3 of 81 equals y, all right, how do we solve this? This is what it's saying. It gives it to you in logarithmic form, correct? We want to take this logarithmic form and break it down into exponential form. Okay? So, what is the base in number 1? What's my base? 3. Raised to this y equals this 81. Correct? Now, what I want to do is I want to set my bases equal to each other. Because what I know about exponents is if I have the same base, I can drop the base, set the exponents equal to each other. Okay? So how would I figure out what 81 is in terms of 3? Well, if I divide that by 3, I'm going to get 27 times 3. Correct? And then what do we know about 27? Well, I know 27 is 9 times 3. Correct? And then 9, I know that is 3 times 3. Well, how many 3s do I have? 1, 2, 3, 4. So 81 is 3 to what power? The 4. So we have 3 to the y equals 3 to the 4. Are the bases the same?
Yes.
Yes, they are. So drop the bases, set your exponents equal to each other. What is y? That's your answer.
But just wait, you're gonna add 15 more steps.
I am
And then
not.
it's not gonna be.
Actually, I am not.
Please.
Okay, look at this one.
It'll always get it too.
All right, look at this one. Log base 5 of the square root of 5. You set off with 5.
It always happens. I understand.
I'll
Coach,
give you some.
Coach Givens last year, he had a bucket of gum.
Thank you.
He just didn't pass out.
That was nice for you.
Oh, this. Tim used to keep me just full of candy last year at practice. He was lucky to-
I can't now.
I know.
Nothing if I hide it. Just like,
Put it in your, put it in your sock.
Put it in your girdle.
put it in your sock.
Put it in your girdle.
I put
Like Barry put the phone.
Why would you put it in his girdle? Best idea I've ever
No,
had.
good.
Best idea.
Barry used to keep his phone in his girdle.
There he is.
Dude, did you hear that? Oh, no, we already started.
This is what we know. We can take this radical. That is a radical. A square root is a radical. Okay? Let's say we have the nth root of x to the y power. That's a radical. We can put this in exponential form with a rational exponent. What is rational? What is a rational number? Give me an example.
2.
Yeah. Okay, give me what is a rational number? What's the definition? A number that stops or repeats. 1/2 is a rational number. 2/3 is a rational number. Correct? What's 2/3 is a decimal? 0.6 repeating, right? Okay. So I can take this radical and set it equal to x to the y over e. Based off of what power you're raising the radicand by, what it's called, and what root you're taking. Alright? So, based off that, how would I put that in exponential form? What are we raising the 5 to? Inside the radical, right here. Right? There's nothing there. If there's nothing there, it's understood it's a 1, right? So we have 5 to the y equals 5 to the 1 over, what's the root we're taking? The square root. There's nothing there. Square represents what? 2. 1/2. So square root is 1/2 as a exponent. Okay? So, are your bases the same? Yes, that's your exponent. Question so far. All right.
What do I have to do to see if I can take it in October?
Just go on there. Go on the website.
She said I need to take it ASAP, so. The ACD, I said, why? She said, she gave me with the big C before. I said, don't put it,
I'm back. Hey, y'all.
It's about rain time.
Mr. Green.
It's a great time.
It's a great time.
It's hot in there.
It is. All right. Look at this one. On base 7 of 149. Now, what do we know about 7 and 49? I can break 49 down how? 7 times 7. I agree with that. But, when I put it in exponential, we've got 7 to the y equals 1 over 7 squared. Correct? Here's what I need to know. You need to understand negative exponents. If I have any x to the negative n, that equals 1 over x to the positive n. Can I go in reverse with that? Absolutely. If I have 1 over x to some positive exponent or a negative exponent, change the sign of the exponent, put it in the numerator. What's the sign of the exponent here? Positive. So to put it in the numerator, make it negative. So we have 7 to the y equals 7 to the negative 2. Are your bases the same? Yes. Set the exponents equal to each other. Does that make sense?
This is easier than what we did.
I heard
Well,
that.
that's not hard.
I know it's not hard.
Wait, so what are we doing?
Logarithmic functions.
Is there more to it? Does it get harder?
Today, no. I mean, we're going to add stuff to this, yeah, but it's not. I don't think it gets harder. All right, look at this one. What if we have? Here's an easy one. 2's raised to here? 1. If I put this in exponential, that's 2 to the y equals 2 to the first. Drop the 2's, y equals 1. All right? Questions on this?
No, but I didn't get in here. I already know what that is.
Hand it over to
I'm pretty
What?
proud.
Hand it over to that,
What?
that answer.
Because everything is on board.
Hey, y'all don't give me enough credit. I'm actually pretty smart.
All right, so really we have 3 types of logs. Okay, we have a log where there is a defined base. Okay, that like what we've been doing. We have common logs and we have natural logs. Those are the 3 types of logs we have. Common logs always have a base of 10. There won't be, it'll just say log. There won't be a base listed. If you just see the word log, then you understand that's a common log. We have a base of 10, automatic. Okay, so if we have this problem, the log of 0.001 or 1/1000, correct? Here's what I would do. What's the base? 10. Right? It's understood. There's nothing there, so it's a common log of 10. So we have 10 to the y equals. I would put this as a fraction. How would I write that as a fraction? 1 over 10. Can I write this as a base of 10, right? Power of 10? Absolutely. This is 100 times 10. Well, that's 10 times 10. How many 10s do we have? 3. So we have 10 to the y equals 1 over 10 cubed. How do we take that 10 cubed and put it in the numerator? Make it a negative. Make your exponent a negative. We have 10 to the y equals 10 to the negative 3. Are your bases the same? Drop the base, set the exponents equal to each other. Y equals negative.
Okay, why did we change the 3 to negative 3?
Because of the rule of negative exponents. That exponent is in the denominator, correct?
Yes.
If it's in the denominator, I need it to be in the numerator. The only way I can do that is to take that exponent and make it negative.
Okay.
And that puts it. And then if you have a negative exponent, you can make it positive by putting 1 over it.
Okay.
Alright? What if we have... Alright, look at this rule. B raised to the log base B of x equals x, always. If this base and that base are the same, it always equals x. Or it always equals whatever you're taking the log of. Alright, for example, if we have... What's the base here? It's common log, right? There's not a base, it's not a defined base. So what's the base? 10. Is that base and this base the same? Yes, so that's always the answer. Whatever that is always the answer. What I'm taking the log of. That's just based off this rule.
So when there's a 10 before the log, then the exponent is
Well,
always-
not necessarily always. It could look like this. It could say 4 to the log base 4 of 19. What would the answer be? 19. Based off of, are these two the same? Does that make sense? All right, the next type of log we have, that's a common log. We've talked about defined logs, common logs, and we have a natural log. Okay, natural log is represented by LN. Right? And it has a natural base of E. When you see E, don't freak out. E is just, it's an irrational number that was created by Leonard Euler by taking the limit as x approaches 0 of 1 plus 1 over x raised to the 1 over x. That's what E is. It's about 2.718. It's on your calculator. It's an irrational number. It goes on for forever. Okay, but that's what E represents. So you understand when you see E, it really represents a number about 2.7. Okay, but
you also need to understand that if you have E, if we have the natural log of E to the 7th, what's the answer? Let's put it in exponential form. What's the base? That's a natural log. Natural log has a natural base of E. So the base is E to the Y equals E to the 7th. Are the bases the same? Drop them. Set your exponents equal to each other. Y equals 7. Alright? Does that make sense? Alright, what if you have this? What's the answer?
So it would be 6.
6 is the answer. The natural log has a natural base of E. That E is the same as this E, so the answer is always what we're taking the natural base of.
So the
Natural
E
log.
is like 10.
Yeah. Questions, comments, concerns, thoughts, or anxieties? Everybody feel pretty good?
You put 1, 2, 3, 4, 5, 6, then you have 7.
Yeah.
I know.
No questions, we're good?
Well, I had, like, what did I miss?
I'm gonna stop one.
1 and 2.
So you're just kind of,
1, 2, and 3, actually.
so you're just trying to break them down.
Yes. Take the logarithmic form, put it in exponential, and then solve for y. All right, on page 178, we're doing 2 through 24 even.